All right, guys, this problem says find the values of the 6 trig functions down here for angle theta in standard position given the following information. And they give us that the cosecant of theta is the square root of 3, and also that this is in quadrant 2, okay? Quadrant 2. So it's a little bit tricky, but we need to remember, first off, quadrant 2, this is my x and y axis, is going to be in this region up here, the top left. All right, so I'm going to draw a triangle. Probably not going to be accurate because we don't know all this information yet, but what we do know is that this value down here is going to be a negative, and this value is going to be a positive because it's in quadrant 2. Okay. Other things is this is going to be our theta. All right, and then we know that cosecant of theta is the square root of 3. So I can put that in as one of my 6, square root of 3 right here. And remember, cosecant goes kind of hand in hand with sine. So if you know cosecant, you can plug it in, that's fine, you can do that. But I like to always kind of transfer back to either sine, cosine, or tangent. In this case, it's opposite of sine. So we're going to take this fraction, if I put it over 1, and flip it to make this 1 over the square root of 3 to find sine in here. All right, when I do that, compared to theta, 1 over the square root of 3, if we have sine, we're going to have opposite over hypotenuse. So I'm going to have positive 1, keep my positive there. And up here, I'm going to have the square root of 3. Okay? Now, some of you might be screaming at me that this is not rationalized. You're right, so we would have to finish that one out. I'll just do it now, so we don't have to think about it. And that's going to be the square root of 3 over 3. Okay, this one was already given to us as the square root of 3. Okay, and then I need to find this value down here. It's going to be negative, what I find. So we're going to use the Pythagorean theorem, but we just have to make that value negative once we find it. So let's see what we have. This is my a squared and b squared. We're going to have a squared plus b squared equals c squared using the Pythagorean theorem. And I don't know a, so I'm going to keep that as a squared. B squared, we're going to call 1 squared. And then c squared is going to be the square root of 3 squared. All right, so if I work that out, 1 squared is still 1. A squared we don't know either. So a squared plus 1 equals the square and the square root cancel for the square root of 3, so that gives us just 3. If I subtract 1 on both sides, a squared equals 2. So the square root of a is going to just be the square root of 2. All right, square root of 2. And remember, it has to be negative. So I'm going to put my negative square root 2 here. Negative because we're going backwards on our x-axis. All right. Once we have all 3 of these, we can fill out the rest of our trig functions. And let's start just with cosine. That's next. So cosine is going to be adjacent over hypotenuse, or negative square root of 2 over the square root of 3. It's kind of interesting. It has a 2 and a 3 as both square roots. So to rationalize this, we have to take it times our denominator square root, which is the square root of 3 over itself, giving us negative square root 6 over square root of 3 times square root of 3 is 3. Notice that these do not simplify. One's on the inside and one's on the outside. It has to stay like that. Tangent compared to theta is opposite over adjacent, which is 1 over negative square roots of 2. I'm going to put this negative out front, just make it negative 1 over the square root of 2. Then I'm going to rationalize my denominator. So that gives us negative square root 2 over 2. All right, secant, again, we can flip this, or we can go back to a previous version, which was negative, and then I'm going to flip these ones, make it square root of 3 over square root of 2. And if I rationalize the denominator here, multiply times the square root on the bottom, that gives me negative square root 6 over 2. Again, those do not simplify, it has to stay like that. All right, then lastly, I can go back to a previous version of tangent, which was maybe negative 1 over the square root of 2, and flip those to be negative square root of 2 over 1, which just becomes negative square root of 2. All right, we successfully found all 6 of our trig functions given this information here with theta in our standard position.